Imagine, if you can, a lake at the bottom of the ocean, thousands of feet beneath the waves, so deadly that any creature unfortunate enough to swim into it dies almost instantly, its body perfectly preserved by the very water that killed it. This isn't science fiction, it's a real place in the Gulf of Mexico, nearly 3,300 feet deep, known chillingly as the Jacuzzi of Despair. It's an extreme environment that challenges everything we thought we knew about life, and surprisingly, it might hold the key to finding alien life beyond Earth. But how does such a bizarre and deadly feature come to exist in the first place? The story begins millions of years ago, long before the Gulf of Mexico even took its current shape. During ancient geological periods, vast inland seas repeatedly evaporated, leaving behind enormous, thick layers of salt. Over eons, these salt deposits were buried under layers of sediment and rock. As the continents shifted and the seafloor evolved, these buried salt layers became unstable. Tectonic activity, pressure from overlying sediments, and even the sheer weight of the ocean itself caused these salt deposits to move, twist, and sometimes, rupture. When faults or cracks occur in the seafloor, seawater can seep down, sometimes miles deep, encountering these ancient salt beds. The water, now under immense pressure and often heated by the Earth's interior, dissolves the salt, becoming supersaturated. This incredibly dense, supersalty water then finds its way back up through fissures in the seabed, pooling in depressions on the ocean floor. Think of it like this: if you pour oil and water into a glass, they separate into distinct layers because oil is less dense. In the deep ocean, the supersalty brine is so much denser than normal seawater that it acts like a separate liquid, forming an underwater lake with its own distinct surface and even shoreline. This process of salt dissolution and upward seepage is how these unique brine pools, including the Jacuzzi of Despair, are born. To understand the Jacuzzi of Despair, we need to grasp the sheer extremity of its environment. Its water isn't just salty, it's 4 to 5 times salter than the surrounding ocean, making it incredibly dense. This density difference is so profound that a submersible can literally float on its surface, as if it were a solid ground. But density isn't the only killer. The brine is also anoxic, meaning it contains absolutely no oxygen. For most complex life forms, oxygen is essential for respiration, the process that fuels their cells. Without it, survival is impossible. Adding to this cocktail of death, the brine can also be surprisingly hot, with temperatures reaching over 60 degrees Celsius, or 140 degrees Fahrenheit. For a deep-sea environment, that's scorching. So, what happens if a fish or crab accidentally swims into this underwater lake? The moment it crosses that shimmering, distinct surface, it's a death sentence. The extreme salinity causes rapid dehydration and cellular shock, effectively pickling the organism. The lack of oxygen suffocates it almost instantly. The high temperature adds to the cellular breakdown. But here's the twist: the very properties that kill also preserve. The highly saline, anoxic conditions prevent decomposition, meaning the bodies of unfortunate creatures that fall in can be found perfectly preserved on the shores and within the brine pool itself, a macabre testament to its lethal power. It's a natural mummification process, playing out thousands of feet below the surface. Yet, despite its lethal embrace for most ocean dwellers, the Jacuzzi of Despair is not entirely devoid of life. In fact, it teems with it. But not the kind of life you might expect. At the very edge of this toxic lake, and even within the brine itself, thrive incredibly resilient microorganisms known as extremophiles. These are single-celled organisms, bacteria and archaea, that have evolved extraordinary adaptations to survive and even flourish in conditions that would be instantly fatal to nearly every other living thing. They don't breathe oxygen; instead, many utilize chemosynthesis, deriving energy from chemical reactions with compounds like methane or hydrogen sulfide, which are abundant in the deep sea, often seeping from the seafloor. They have specialized proteins and cell membranes that prevent their internal structures from being destroyed by the extreme salinity and temperature. These tiny survivors represent a parallel tree of life, one that utterly defies our conventional understanding of habitable zones. This resilience of life, thriving in such an utterly hostile environment, is precisely why the Jacuzzi of Despair holds such profound significance for astrobiology, the study of life beyond Earth. When scientists search for life on other planets or moons, they often look for environments that could support liquid water. Moons like Europa, orbiting Jupiter, or Enceladus, orbiting Saturn, are thought to harbor vast subsurface oceans beneath icy crusts. These oceans are likely dark, cold, and potentially devoid of oxygen, but they could contain hydrothermal vents or other chemical energy sources, much like Earth's deep-sea environments. The Extremophiles of the Jacuzzi of Despair offer a tangible, earthbound model for what alien life might look like, how it might survive, and what chemical signatures we should be looking for if we were to send probes to these distant, watery worlds. It expands our definition of habitable in ways we previously thought impossible. The Jacuzzi of Despair isn't just a curiosity, it's a living laboratory, a testament to life's incredible tenacity and adaptability. It teaches us that life finds a way, even in the most unforgiving corners of our own planet, pushing the boundaries of what we conceive as livable. Studying these unique ecosystems helps us understand not only the biodiversity of our oceans but also the fundamental principles of life itself. It fuels our imagination for what might be out there, lurking beneath the ice of distant moons, reminding us that the universe is probably far more alive, and in stranger ways, than we could ever have dreamed. What other secrets lie hidden in the extreme places of our deep ocean, waiting to redefine our understanding of existence? The journey into the unknown continues, one extreme place at a time. If you're fascinated by the mysteries of our deep blue planet and the potential for life beyond Earth, make sure to like this video, subscribe to our channel for more deep ocean documentaries, and share your thoughts in the comments below. We'd love to hear what you think.